This video will present solutions to the VCE 2020 Mathematical Methods Written Examination 2, Section B, Question 3. This question involves the distribution of t, the number of minutes late or early an item is delivered. T is modelled by a normal distribution with mean 0 and standard deviation 4 minutes. Part A. We are asked to find a value of A such that the probability of t less than or equal to A is equal to 0.6. We can find this A value using the ClassPad's inverse normal CDF command. To the nearest minute, the answer is A equals 1. Part B. The conditional probability that an article is no more than 3 minutes late, given that it is late, can be calculated as the probability that t is between 0 and 3 divided by the probability that t is greater than 0. The numerator of this fraction can be evaluated using the ClassPad's normal CDF command. As the value of the denominator is 0.5, due to the distribution symmetry about its mean of 0, then our answer can be found by dividing this probability by 0.5. Part C. This question involves a changed mean and some information about the probability of t between negative 4.5 and 0.5. We can gain some insight into this new mean by setting up an equation involving the normal CDF command. So it seems we have two answers. However, this question is worth 3 marks that suggests that some reasoning should accompany these two answers. If we notice that the interval of t between -3 and 2 has been shifted back to -4.5 to 0.5, then the reasoning behind k equals -1.5 is a horizontal translation of the curve by 1.5 units to the left. But what about the solution k equals -2.5? The reasoning behind this involves a reflection in the line t equals 0, followed by a horizontal translation of the curve. These area-preserving transformations are the reasoning behind this value of k. This question now pivots to a rival delivery company which claims to deliver on time or early 85% of the time. Combined with the assumption of independence, this claim provides the basis for us to use a binomial distribution to answer parts D and E. Part D. Using a binomial distribution with n equals 8 and p equals 0.85, we can find the probability of 3 or fewer on-time or early deliveries, as 3 or fewer constitutes a half of the 8. This probability can be evaluated using the ClassPad's binomial CDF command. Part E, Part 1. We are now considering a day with n deliveries and focusing on the number of deliveries that arrive late. The probability that 1 or more out of n arrive late is equal to 1 minus the probability that all arrive on time or early. Based on the formula for binomial probability, this statement can be written as an expression in terms of n. Part E, Part 2. This part asks us to find the minimum value of n such that the expression found in Part 1 has a value of 0.95 or greater. This equation can be solved using logarithms or a ClassPad. Based on this solution and the fact that n is integer, our answer is n equals 19. Part F. Based on the information provided about an analyst's beliefs, we have an overall probability of an on-time or early delivery being 0.75. However, this 0.75 probability is actually the probability of one of two scenarios. Either the delivery is made before 4 and is on time or early, or the delivery is made after 4 and is on time or early. If the probability of a delivery being made after 4 is y, and such a delivery is on time or early with probability x, then combined with the probability of a before 4 delivery being on time or early remaining as 0.85, this probability relationship can be expressed in the following equation. This equation can be rearranged to get y in terms of x. This relationship between y and x is in the form of a simple rational function that looks like this. Based on the nature of the relationship between x and y in the vicinity of 0.3 to 0.7, the smallest and largest values of y will be found by substituting the smallest and largest values of x into this equation.